What's that? 3.3 notes is going to be working with proving lines parallel. So we're going to be working with converses of the statements that we already know. So our goal is to use the transversal and angles to prove lines parallel. So our recap, these are all postulates and theorems that we already know. I want you to read through them and fill them in. Okay? Now these are converses. Converses are switching them. So let's see if you can go through and write our postulates and theorems that we already know. And if you don't know them, then look back at your 3.2 notes because they're all written on your 3.2 notes. Literally copied and pasted. Okay, so you might have to look back at them. Then the corresponding angles postulate, I want you to look down here at the converse of the corresponding angles postulate and see if you can work at writing the converse. So this front side of the notes you are going to do all on your own. Does that make sense? And then we'll talk about them. And I almost forgot, but if you can write the converse, then you can flip it over and we can write the biconditional of those 5 statements as well. So those are that's what you're working on, writing those postulates and theorems, which we already know, writing the converses. Once you have the converses, because those are also true, we're going to move on to writing the biconditionals, which are on the back side. And theorems. Okay, so back to the first one. Let me unfreeze this. There we go. To use the transversal and angles to prove lines are parallel. That's our goal today. We're going to be using the converses. Because all of the originals start with if you have a transversal that intersects 2 parallel lines. So if you have parallel lines, then we have corresponding angles that are congruent. We'll have alternate interior angles that are congruent. We'll have alternate exterior angles that are congruent. We'll have same side interior angles that are supplementary. We'll have same side and exterior angles that are supplementary. So if we have parallel lines, then we have all of these special angles that will be either be congruent or supplementary. And it's really important that you understand that the lines must be parallel for that to happen. Okay? So the abbreviation here, like the way you can think about it, if you want to make a flashcard, maybe you want to make it a little simpler on the flashcard. If parallel lines, then corresponding angles are congruent. If parallel lines, then AIA congruent. Okay, does that make sense? Okay, that's review. That's all old stuff. That's stuff we focused on the other day on Tuesday. The converse, though, is then going to be a little bit different. The converse will say if 2 lines and a transversal form corresponding angles that are congruent, then the lines are parallel. Okay? So now for the converses, we have to have those relationships happening, and if that's happening, then we can say that the lines are parallel. So the converse of the alternate interior angles theorem will say if 2 lines and a transversal form alternate interior angles that are congruent, then the lines are parallel. Okay? The converse of the alternate exterior angles theorem says that if 2 lines and a transversal form alternate exterior angles that are congruent, then the lines are parallel. Okay? So let me give you an example here. We're going to write in an example from this. Yes?
For the then, I wrote the transversal intersects 2 parallel lines.
Then a transversal intersects 2 parallel lines. That would work. Yep, it's just a little bit more descriptive. The reason why you don't have to say the transversal intersects 2 parallel lines, because it talks here about 2 lines and a transversal. Okay? So basically the 2 lines are what's going to be parallel. The transversal can't be parallel to it because in order for it to be a transversal, it has to intersect those lines. It has to go through those lines because that's what transversal means. It goes through something. Okay? So you don't have to put that detail, but if you did, that's totally fine too. That's not wrong. But I wanted to give you an example. So for example here, if we were told that angles 8 and angle 6 Okay, if we were told that angle 8 is congruent to angle 6, grab a different pen. Then we know that L would be parallel to M because 8 and 6 are corresponding angles. So if I know that 8 and 6 are congruent, I can then say, okay, L and M are parallel because corresponding angles are congruent. Does that make sense? For this one, if I said these are alternate interior angles, so if angle 7 is congruent to angle 3, then I know that L is parallel to M. Okay. If these ones are alternate exterior, so let's say I said angle 1 is congruent to angle 5. I was going to write out the name 5. No, 5. Okay, angle 1 is congruent to angle 5. That would tell us that L is parallel to M. Remember, if you draw just the arrow like this, that implies, so that means it's an if this, then this. That arrow tells you it's an if-then statement. Okay. But what about same side interior angles, like 2 and 3? What if I said that angle 2 is congruent to angle 3? What would that tell me? Nothing. Why? What do 2 and 3 have to be? They're same side interior angles that are supposed to be what? What's supplementary mean? Add to 180. Not that they're congruent. 2 and 3 would have to add to 180. Okay, their measures, measure of angle 2 plus the measure of angle 3 would have to add up to 180 to imply that L is parallel to M. Do you see the difference? Okay. Same side exterior angles would say that the measure of angle 1 plus the measure of angle 4 would equal 180. That would imply L is parallel to M. All of those would be examples of how we could use this. So if we're given that something is congruent or supplementary, if it meets one of these theorems, then you can conclude that lines are parallel. So because they have a conditional and a converse that are true, we can move on to write the biconditional statement. So the biconditionals read, a transversal intersects two parallel lines if and only if corresponding angles are congruent. Okay? A transversal intersects two parallel lines if and only if alternate interior angles are congruent. Transversal intersects two parallel lines if and only if alternate exterior angles are congruent. You could have abbreviated parallel and used that abbreviation, parallel. They kind of look like sideways L's almost, kind of like the double L's in parallel. Okay, that's our abbreviation for parallel. That would have actually fit a little bit better on that line than me over writing all those words, but that's okay. Okay, so that's how the biconditionals will read. What's that? All right, okay. All right, so then let's work on this example. Okay, so let's say I give you angle 14 and angle 18 are supplementary. Let's look at 14 and 18. Okay. Now, I'm going to zoom in on this. 14 and 18. When we zoom in on this, what it will help for you to do is if you highlight the two lines that form 14. See how only two lines form an angle? Okay, so see how those two lines formed 14? And then 18 is going to be this J line along with this N line. Okay, and that's where I was saying if we had patty paper, which I wish I knew where mine was, this would help because what you can do is we can kind of zoom in on this is 14, this is 18. So this is what we're looking at. This is what we're working with. This is M, this is N, this is J. And then sometimes that's a little bit easier to look at the two lines in the transversal than looking at the whole big picture. Okay? So what we need to come up with is if 14 and 18 are supplementary, what can we conclude? If I know that 14 and 18 are supplementary, what can I conclude? Go ahead.
The angles are
Okay, the angles are going to add up to 180, but there's something more. Go ahead. What lines are parallel? What two lines? M and N are parallel. So the way I'm going to write this is I'm going to write that they're supplementary. M is parallel to N. And that's why sometimes it helps if you have that patty paper. I'm going to see if Mrs. Pierce has some I can borrow. But if we have the patty paper, then you can really see what two lines are going to be parallel, because you have to zoom in and tell me what two lines are parallel. And what is our reasoning here? How do we know that those two lines are parallel? What says these kind of angles are supplementary, then the lines are parallel? SSI, they are same side interior angles, but are we going to be talking about the theorem here or the converse? The converse. If we're concluding parallel, so it goes this direction. If we conclude parallel, that's the converse. If we start with parallel, that's the theorem. Do you see the difference? Okay. This one, the next one, you're given. I'm going to try to do different colors here for everything. You're given that angle 4 is congruent to angle 5. That's what's given. Okay? Then we have, this is what we're trying to conclude. And then we're going to state how. So let's find 4 and 5 here. 4 and 5. And I'm going to highlight the lines that create 4. I'm going to highlight the lines that create 5. So if I used some patty paper, or in this case I'll use a Post-it, I highlighted J, K, L, 4 was here, 5 was here. So this is what I'm looking at. And 4 is congruent to 5. What does that tell you? J and K are parallel. So J is parallel to K. What would be my reasoning? What kind of angles are 4 and 5, and what relationship do they have? The alternate exterior angles are congruent, so the lines are parallel. So alternate exterior angles, is this a theorem or a converse? Which one says if the AEA are congruent, then the lines are parallel? The converse. The converse ends in parallel. Okay, that's why it's important that you make the flashcards so you know the difference between the theorem and the converse. Okay? Because you would get marked down on a test if you just wrote AEA theorem and not the converse. They are two different things. Okay? All right, so the next one we are given says angle 21 and angle 11 are supplementary. So let's look at 21 and 11. And we're trying to figure out what can we conclude from that. So 21, let me form these lines. 21 is formed by, that's N and J. And 11, 11 is formed by M and K. And 11's right here. Rut row. Why'd you say rut row?
they're far apart.
They are very far apart. What are you thinking?
Oh, I just have a question.
Okay, what's your question?
So if you start with a parallel, that's the theorem?
If you start with parallel and go to those relationships, then yes, those are theorems. Unless it's corresponding angles, then it's the postulate. But if it is ending with parallel, that's when it's the converse. Yes. What were you going to say? Yeah. It says they are supplementary, yes, but what does that tell us? What kind of angles are these? What kind of relationship do those have? What is it?
Pay attention, please. Can I have sophomores? The rest of the sophomores, please go to PhD for retake.
That all 4 lines are parallel.
Mm-mm.
No.
If you cannot identify a relationship between 21 and 11, okay, which you cannot do unless you're looking at 2 lines and a transversal. 2 lines and a transversal are how many lines? 3. 2 lines and 1 transversal make 3 lines. How many lines are here?
4.
That can't create any of those relationships. It can't create corresponding angles or same side interior angles or same side exterior or alternate interior, alternate exterior angles, because it's not 2 lines and a transversal. You have 4 lines there. So because of that, when you have 4 lines, your answer is always going to be not possible. You can't do anything. Because in this case, we have 4 lines. You can't identify which 2 would be parallel if you have 4 lines.
If all the numbers are on there though, can't you just like use 9 and then go over it?
But we would have to have the relationship with 20, you said what, 9? We'd have to have the relationship given that 21 and 9 had a relationship.
And you go.
We don't know. Because these are not marked parallel. So if you're saying that they do have a relationship, then you're automatically assuming they are same side exterior angles, but that doesn't guarantee us that they are supplementary unless we were told that the lines would be parallel.
You did.
These are 4 separate problems.
Oh.
Okay. Yeah, we can't go off of these lines being parallel because we proved it. These are like 4 separate problems, but we're using the same diagram. Okay. All right. The last one says that angle 2, let me get a different color here. Angle 2 is congruent to angle 5. 2 and 5. I'm going to draw that on my diagram here. 2 is made up of these 2 lines, L and J. And 5 is made up of the same 2 lines. Okay, and I'm told that 2 and 5 are congruent. What's that tell us? What lines are parallel? Are L and J parallel? Look at L and J, they intersect. They can't be parallel. Those are what form angles 2 and 5.
Yeah, that's not what.
We're trying to identify 2 lines that are parallel here. Do you even have another line to say it's parallel? No, why? What kind of angles are 2 and 5?
Vertical.
Those are vertical angles. Aren't vertical angles always congruent? So it doesn't give us any other information. You only have 2 lines there, so there can't be 2 lines and a transversal, 2 parallel lines and a transversal. You're only having 2 lines. So this is not possible. You can't do anything if you're given vertical angles congruent. Vertical angles are always congruent. Or you can say something along the lines of 2 lines. They're only given 2 lines there, not 3 lines. You have to have 2 lines and a transversal, which are 3 lines to identify parallel lines. Okay. All right, we do have one proof that we're going to do together, and then you guys are going to have some time to work on your assignment. Okay. And then we'll take a little break, and we're going to do another thing of notes that have more proofs on them. They won't be anything. Again, you don't have to prove anything on your own yet. We do not have, I'm not giving you any proofs to do on your own, okay? We are just practicing proofs together, so don't freak out about them. Okay, so given that 1 and 6 are supplementary, how I'm going to start this is I'm going to write my given. So I'm going to write out that given, here's my reasoning, okay, angle 1 and angle 6 are supplementary. My reason, given. Okay. I also know that since I'm trying to prove P is parallel to Q, that's going to be my very last step here. But I don't know what my reason's going to be because my reason will be how I get from 6 to 7. Okay. If these two angles are supplementary, what does the definition of supplementary tell you? They add up to 180. So let's write that out. The definition of supplementary would be my reason there. That the measure of angle 1 plus the measure of angle 6 is equal to 180. Okay. So I know that 1 and 6 are supplementary. I know that the measure of angle 1 plus measure of angle 6 has to equal 180 because that's the definition of supplementary. What else do I know here? Let's use the linear pair theorem. Let's work with 1 and 2. Are 1 and 2 linear pairs? Let's state it. Angle 1 and angle 2 are a linear pair. How are two angles a linear pair? How can I say that they're a linear pair? Not the linear pair theorem. The linear pair theorem says that if two angles are a linear pair, then they are supplementary. How can I say that 1 and 2 are a linear pair? They follow the definition of a linear pair. So the definition of a linear pair will tell me that two angles are a linear pair. If you can see it, it follows the definition. Okay? What do we know if 1 and 2 are a linear pair? Let's use the linear pair theorem now that we know that they're a linear pair. What do you know about angles 1 and 2? They're supplementary, which means that what? They add to 180. So measure of angle 1 plus the measure of angle equals 180 because of the linear pair theorem. And technically the definition of supplementary, but that's okay.
Wait, can you do both of them?
The linear pair theorem and definition of supplementary?
Or just definition?
You can't do definition of supplementary because you have to use the linear pair theorem to say since they are a linear pair, then they are supplementary. Technically, I would say 1 and 2 are supplementary, then put this section and say linear or definition of supplementary. But I just did them in the same step. That's okay. Okay, so I know that 1 and 6 add to 180, and I know that 1 and 2 add to 180. So if both of those add to 180, that means that the measure of angle 1 plus the measure of angle 6 must equal the measure of angle 1 plus the measure of angle 2. Do you see that? Do you see how if this equals 180 and this equals 180, then these two must be equal? Okay, what would be my reasoning there?
The measured angle 6 equals measured angle 1.
That would be my next step. That would be my next step is that you said the measure of angle 6 has to equal the measure of angle 2 because they're both adding measure of angle 1 on both sides. So if you subtract the measure of angle 1 on both sides, yes, the measure of angle 6 will have to equal the measure of angle 2. Okay, but, and you're subtracting, so cool, that would be the subtraction property of equality, but we still didn't fill in this one. Why is it that if this equals 180 and that equals 180, then this equals that? The transitive. Yes, you could use either transitive or what else? What else would work here?
Substitution.
Substitution. So I don't care if you write down transitive, property of equality, or substitution there. Okay, and then the measure of angle 6 equals the measure of angle 2. Well, let's look at those. 6 and 2 are the same. How do we go if 6 is equal to 2, then the lines are parallel? Go ahead. Yes, what's your question?
Wouldn't it be property of congruence with the angle?
Oh, we did the measures. Measures are equal.
Oh,
Measures of angles are equal. If we were talking about angles, then yes, we would say property of congruence if that was a congruent symbol. But since we're talking about the measures of the angles, they are equal, not congruent.
Corresponding.
It is the corresponding angles what? We go from if 2 and 6 are the same, then the lines are parallel because corresponding, we can abbreviate it CA. Corresponding angles what? The postulate says that if two lines are parallel, then corresponding angles are congruent. Did we start with parallel here? No, we ended with parallel, so it has to be what? The converse. The corresponding angles converse. The reason why we can use this in a proof is because this is a postulate. Okay, the postulate is the one that we assume to be true. We have to use that postulate to prove because the theorems are what we have to prove. Okay, since we started with corresponding angles that are congruent, then we went to parallel lines. That's how we knew it was the converse versus the postulate. Okay, it's the converse of the postulate. Does that make sense? Okay,